Alright, I decided to learn C, which if you don't know, is basically programming without a seatbelt. No safety nets, no friendly error message. If you mess up, your program doesn't just politely complain, it simply just explodes, which is comforting. Now, most normal people learn languages by writing something like, hello world, maybe a calculator. But I thought, why not immediately attempt something slightly dangerous? So today I'm going to be building a dynamic inventory system in C. You know, like the inventories you see in games where you can add 1 sword, add 2 potions, maybe add 10 shields. I don't know why you would ever need 10 shields. Maybe you're preparing for an extremely aggressive frisbee tournament, but that's the goal. A working inventory that can grow as we add items. Simple idea, absolutely horrific execution. Because computers don't understand inventories, they only understand memory, which means if we want an inventory, I have to manually design what it would look like inside of memory. Which is when I realized something very important. I had absolutely no idea what I was doing. Like none. This entire project began with me longingly staring into a blank terminal, thinking, surely someone smarter than me has already suffered through all of this. So naturally, I went on a 3-hour research journey consisting of YouTube videos, Reddit threads, and one suspiciously confident guy on Stack Overflow who solved every problem by yelling, just use a pointer. Which brings us to the first block, the item. Because an inventory is just a bunch of items. So what does an item need? Well, a name and a quantity. You should be able to name something like sword and have quantity 1, or potion and have quantity 2, and shield and have quantity 16. My idea of extreme shield frisbee is actually kind of kicking off with the kids in my neighborhood. Now, in C, when you want to group pieces of data together, you use something called a struct. A struct is basically a little container. Think of it as a custom box where you can store related information. Inside my item box, I put 2 things. A pointer to a character array for item names, and an integer for the quantity. Originally, I tried storing the name as a fixed array, which technically works and is probably easier, but it also means every item will reserve a huge chunk of memory, whether it needs it or not. If somebody enters in something like axe, suddenly a 3-letter word is sitting inside a 50-character box, like a toddler in an Olympic-sized swimming pool. So because I hate myself, I decided to switch to pointers to characters instead, which means the program will allocate exactly the amount of memory needed for the name. Efficient, dangerous, very C. After an unreasonable amount of research and one very helpful YouTuber with a magnificent Indian accent, I finally had something resembling an item structure. And for the first time during this project, I thought, okay, yeah, maybe this might not be impossible. And I tried to build the inventory and everything immediately went wrong. Because the inventory needs to store multiple items, which means we need some kind of list, an array. Easy, right? Wrong. Arrays in C are fixed size, which means if you create an array that holds 5 items, that's it. 5 items forever. If you try to add a 6th item, the computer basically shrugs and says, you should have planned better, which obviously isn't what we want. Because how are we going to store our 16 million shields for our extreme shield frisbee match? Our inventory needs to grow because you pick up new items all the time. The inventory needs 3 pieces of information. First, a pointer to an array of items. Second, the size, which tells us how many items are currently inside. And third, the capacity, which tells us how many items can be in the array before we run out of space. If the size reaches the capacity, we expand the memory. Simple concept, right? Absolutely terrifying implementation. It's like having a rabbit with a cannon. Have you ever seen a rabbit with a cannon? I mean, I haven't, but I'm assuming it would be absolutely terrifying. It's basically what I imagine I look like while using C. I'm not used to having this much control. Because now we're dealing with dynamic allocation, which means it's time to introduce you to C's most famous and slightly untrustworthy friend, malloc. Malloc is basically you walking up to the computer and saying, hey, can I borrow some memory? And the computer just saying, yeah, sure. Then hands you a random address somewhere in memory and just wishes you good luck. From that point on, it's entirely your responsibility not to ruin everything. Because if you use the wrong size, crash. You forget to free memory, crash. You touch memory that doesn't belong to you, crash. It's like adopting a pet tiger. Your neighbor loves it, the kids love it. In the back of your mind, you know the only reason you bought it is to let it loose in your ex's apartment complex. Well, the inventory initialization function does 3 important things. First, it allocates memory for the inventory structure itself. If that fails, the function returns null because something has gone horrifically wrong. Second, it sets the starting value. The inventory begins with a size of 0 because it's empty, and the capacity of 2 because we need somewhere to start. 2 items, a humbling beginning, like the early days of my social life. Third, it allocates memory for the item array based on the capacity. So if the capacity is 2, we allocate enough memory for 2 items. If that fails, we free inventory memory we already allocated and return null again. Which sounds complicated, but it's basically just responsible memory management. So if everything succeeds, the function returns a pointer to the inventory, which means now we have an empty inventory sitting in memory. And for a very brief moment, I thought I had conquered C. I ran the program, it printed that my inventory was successfully initialized. I felt like an absolute genius malacker. It didn't actually do anything. Couldn't add items, you couldn't remove items, you couldn't even see what was inside of it. It was just an empty box sitting in memory, which means the next challenge was far worse. Now I actually have to build the part where I can add items into the inventory. First attempt, my program immediately crashed, which was very encouraging. So at this point, the inventory technically exists, which is great. Unfortunately, it does absolutely nothing. Right now, it's just an empty structure sitting in memory doing the digital equivalent of standing around holding a clipboard. Very official looking, but absolutely useless. So the next step is obvious. We need to add items. Now conceptually, this is simple. You take an item and you put it in the list. Congratulations, inventory system complete. Unfortunately, computers require extreme detailed instructions, so we have to walk through the entire process like we're explaining it to ChatGPT when you run out of free daily trial. So the first thing the add item function does is check if the inventory is full. Because remember, the array has something called capacity. That's the maximum amount of items it can hold. And if the current size is equal to the capacity, then we're out of space. Which means it's time for one of C's favorite activity, reallocating memory. Relock is basically you walking up to the computer and saying, hey, remember that block of memory you gave me? Yeah, I'm gonna need a bigger one. The computer then finds a new location in memory, copies everything over, and hands you a new pointer. If anything goes wrong during that process, the program just instantly dies. So when the inventory fills up, we need to double the capacity. So 2 to 4, 4 to 8, 8 to 16, which is very important because the shield situation is escalating very quickly. Right now the inventory contains 1 sword, 2 potion, and a concerning amount of shields. Maybe it's because I've started a youth recreational league called Extreme Shield Frisbee, where instead of throwing frisbees, you throw full-size medieval shields at each other while screaming. Which, for legal reasons, I would like to clarify, it's still in the concept phase. Insurance companies have been extremely negative about it. But the point is, we might need space for a lot of shields. So once the program confirms that there's room in the array, we store the item. Name goes in, quantity goes in, then we increase the size of the inventory. And just like that, item added, which was surprisingly satisfying the first time it worked. Because 30 minutes earlier, the program crashed so hard it looked like I was attempting to summon a demon through a null pointer. But now we can add items, which means the next feature we need is removing items. Because an inventory where you can only add items is less like a game mechanic and more like Hoarding Simulator 9000. You pick up a sword, then you pick up a potion, then another potion, then a shield, then 6 more shields because apparently the Extreme Shield Frisbee League is expanding into regional tournaments. Eventually your character is going to be carrying 1 sword, 4 potion, and 28 shields, which raises several questions. First of all, why? Second of all, how? So removing items works like this. First, we search the array until we find the item we want to remove. Once we locate it, we remove it. But there's a small problem. Arrays in C cannot have gaps. If an item disappears, everything has to slide forward 1 position to fill the space, much like the Roman shield wall formation, which historically collapsed when somebody brought way too many shields. Anyways, let's say the inventory currently looks like this. If we remove potion, everything shifts forward. Then we decrease the size of the inventory, item gone. Problem solved. But unfortunately, the shield count is still climbing, which means the final thing we need is searching the inventory. Because sometimes you want to know if something already exists. Like, do we have a sword? Or do we have potions? Or do we already have 17 shields? May need to slow down a little bit. The search function loops through every single item in the array and compares their name. If it finds a match, it returns the index of that item. If nothing matches, it returns -1, which is the programming equivalent of not here, bud. And that's the full inventory system. Now we have a dynamically growing inventory, the ability to add items, the ability to remove items, and a way to search for items, all written in C. All held together by pointers, memory allocation, and a mild sense of danger. And if the inventory keeps growing the way it has been, then there's a real chance that the final output might just look like this.